Good evening, everyone. Today, we will be discussing some of the problems related to the topic biomolecules. So, one of the question which came in 2016 GATE Excel Biochemistry, that is question number 7, and that is entitled as cellulose serves as a structural polymer whereas starch does not. This is because cellulose contains, then there are four options given, which is beta 1 to 4 linked glucose monomers and interchain hydrogen bonds. Option B is beta 1 to 4 linked glucose monomers and intrachain hydrogen bonds. Option C is alpha 1 to 4 linked glucose monomers and interchain hydrogen bonds. And the final option which is given is alpha 1 to 4 linked glucose monomers and intrachain hydrogen bonds. So as you can see that cellulose, the question is about cellulose and starch. And we know that both of them are polysaccharides. So polysaccharides comes under carbohydrates. So let us discuss little bit about carbohydrates. So what is a carbohydrate? Carbohydrates are literally hydrates of carbon. So from its name only, you can see that carbohydrates are a group of biomolecules which are actually hydrates of carbon. This name derives from the generalized formula of simple monosaccharides, which can be written in the form of CXH2OX. So simply, if you consider glucose, which we know is a monosaccharide, so the glucose, if you replace X by 6 in this formula here, so you will get C6H12O6, that is the formula of your glucose. So these carbohydrates are definitely polysaccharides, means they are actually polymerized by certain monomers units, and here these monomer units are these monosaccharides. So these monosaccharides are further divided into different classes on the basis of the ring structure which is present. So here for glucose you can see that it is a 6-member ring structure, whereas for fructose it is a 5-member ring structure. And in the 1' region, that is the first region where this H and OH is present, it is counting when we name this whole chain or the ring structure, we start from this carbon. This is number 1 carbon, and this carbon is actually responsible for the formation of glycosidic linkage with its partner monosaccharide to form disaccharide. So one of the example of disaccharide is sucrose, which is formed by the glucose and fructose, and in between them you can see this is a glycosidic linkage. Whereas for galactose, which is a epimer of glucose, that is in the D, in the 4th position. Then if you count from here 1 2 3 4, so if you consider this glucose and galactose and see the orientation of hydrogen and OH, you will see that in galactose it is just the reverse of glucose. So that's why this galactose is a epimer of glucose. So if we also want to see another example of disaccharide, that is galactose plus glucose is giving lactose. Now when these disaccharides are continuing this chain, means more and more monomers are coming, forming glycosidic linkage and forming a polymer, then it forms a polysaccharide like glycogen. And our molecules of interest in the question, that is cellulose and starch, falls under this category of polysaccharide. Now, if we look deep into the structure of starch, then this starch is made up of amylose and amylopectin. So both of them are polysaccharides, but there is certain difference in their structure. That is, this starch is normally present in the plants, where this starch actually undergo hydrolysis to form glucose and provides nutrition in the time of starvation of the plants, or they are also present in higher amount in seeds where they require higher amount of glucose as the nutrition source. So now this starch is made up of amylose and amylopectin, the maximum of which is made up by amylopectin, that is 70 to 90%. Amylose is a linear polysaccharide where these two glucose are linked with alpha 1,4 glycosidic linkage. So this alpha and beta, this is decided upon the direction in which this OH and H is present. Okay, so there is a convention. If this OH is present in the, means here if you see it is in the right hand side, then it is the alpha linkage, and if it is in the left hand side, then it is a beta linkage. Okay, so here it is in the right hand side, and they are forming a alpha 1,4 glycosidic linkage, and this amylose ultimately forms into a helical like structure, due to which if you add iodine here, it will give you a purple color, since this iodine will be intercalated into this helix, and in each turn there is 6 glucose units present. Whereas this amylopectin is not a linear polysaccharide chain. Instead, there are branching which is happening, as you can see in this structure. That is, there is also this alpha 1,4 linkages present. But after every 25 to 30 units, there is a branching, due to which a kink occurs, which is occurring due to the alpha 1,6 glycosidic linkage in this structure. So due to which there is a branching happening. Now, if we look more closely to the cellulose structure, then in the cellulose it is also made up of glucose. But in the cellulose, these glycosidic linkages, these are actually beta 1,4 glycosidic linkage. And there is also formation of interchain hydrogen bond. Means if, and another thing to note here is, this is like cellulose, that this is like amylose, where you have a linear polysaccharide chain, and these are, each chain is connected to one another by interchain hydrogen bonding, making them much rigid and much linear, so that they can form this extreme linearity allows a great deal of hydrogen bonding between OH groups on adjacent chains and cause them to pack very tightly into fibers. Now let us, if we look into our question, then this is telling that cellulose serves as a structural polymer. By structural polymer, this means that it has to be rigid and it has to pack properly like a fiber. But the starch is not doing that, because it is having branching and it is having kinks, so it cannot be packed so densely like a cellulose. So that's why this starch cannot form these structural polymers. So why, what is the reason, they asked? The reason is, since you see that here they are forming beta 1,4 glycosidic linkages, so that's why the answer will be containing beta 1,4 linked glucose monomers, and also they are having interchain hydrogen bonding, which is absent in this starch. Okay, so that's why the answer here will be option A. Now, for your reference, I have given you two courses that you can look into while going through the biochemistry and metabolism preparation for your GATE exam. So the two courses here is by Dr. Shagota Dasgupta of IIT Kharagpur. So the course name is biochemistry. So this is a very good course for going through your basics of biochemistry and the metabolism part. Also, there is another course by Professor Subramanian K of IIT Madras, and you can also go through this course to have a basic idea about this topic of biochemistry and metabolism.